Hello, this is our solution walkthrough for an implementation of a recursive sorting algorithm called merge sort. Like other recursive algorithms, we solve the problem by magically solving smaller versions of the same problem, which I've referred to as the recursive leap of faith. So if we're going to apply that idea to a sort, the way we would sort an entire array is first we would divide it into two parts, a left half and a right half. We'll recursively sort the left half and the right half by running our same merge sort method. Once you have two halves that are sorted, though, you need some way of putting them back together so that the entire array is sorted, and that's called the merge step. So this is sort of pseudocodey. It does not include a base case, but it, I think, covers the basic idea. So if we're going to merge sort starting from some starting index and ending at an ending index, and more about that in a second, the way we do it is we find the middle index between start and end. Then we merge sort the left half of the array, or rather, not the left half of the array, but the left half of the part of the array that we're searching. And that's why start and end index are important. Because even though in this picture it looks like we're going to take our array, make another array that's half the size, and only copy the left-hand values over, that would take a lot of extra time to constantly be creating arrays and copying values over. So even though in the picture it looks like there's two separate arrays, what we actually do is we run merge sort on the same array. It's just that we change where we're starting and where we're ending so that we can control which portion of the array we're actually going to be looking at. So let's jump over to IntelliJ and we'll start coding up this part of the solution before we get to the merge step. So here we are. I've got a test array. I'm going to display the test array. Then I'm going to run merge sort on the test array, starting at index 0 and ending at the last valid index. So let's create our merge sort. We'll call this array. We'll call this start. We'll call this end. Let's skip the base case for the moment. What I'd said was we'll calculate the middle index. What I'm doing now actually contains a bug that only happens if your array is is so large that these would overflow int. But let's not worry about that for the moment. Okay, so there's the middle index. Now let's run merge sort on the left half. So the array, the left half would have the same starting value, but it would only go up to mid. And then the right half would start at the very next element, and it would go to the ending index. In the event that your array has in the event that the portion of the array we're looking at has an even length, then there isn't going to be a perfect middle index. And so it actually doesn't really matter if we go from start to mid and then mid plus 1. You could go start to mid minus 1 and then mid to end. The exact place where you divide it doesn't really matter. The important thing is that you're starting at the start of the interval, not the start of the array. You're ending at the end of the interval, not the end of the array. And that you're not... the two different halves of the array don't both share mid in common. They have to be separate from each other. Okay. So let's take a look at what the execution tree would look like if we were going to continue to recursively run merge sort on the left half and the right half. It would look something like this. So the original array looks like this. We divide it to left and right. When we merge sort the left half, we do the same approach. We divide it into a left and a right. And then we merge sort the left and we merge sort the right. And then here we divide it into a left and a right and so on. So the base case would be the smallest interval that makes sense where we couldn't actually continue to subdivide it. So that would be an interval of length 1. So if we have an interval of length 1, the way that we test to see if that's happening is if the starting and the ending index are the same, because that would mean they're both pointed at the same element. And so we only have one element to sort, but because one thing is always in sorted order, because there aren't other things that could be out of order, we would just immediately return. So let's put that into our merge sort. If start equals end, then we'll just immediately return. Otherwise, we'll find the mid index and we'll merge sort the left and the right. But then the very last thing we need to do is merge that left and right half together again. So we're going to write a method to do that merge step. Let's imagine that this is a portion of the array that we are running merge sort on. And remember, we're always thinking about the array in general. So we don't know where in the array we are. The beginning of the array is somewhere over here. The end is somewhere over there. Because all we're concerned about is the portion of the array that's between a starting and an ending index, as given by these two parameters, start and end. So let's think about how the merge step would work here for a second. So here on line 13, I calculate the mid index. So the mid index is going to end up being this one. And then I merge sort the left half, which starts at start and ends at mid. So let's pretend now that this has become sorted. So we do 1, 5, 9. And then we run merge sorts on the right-hand part, starting at mid plus 1 and ending at end. And so let's pretend this becomes sorted now. So this would be 2, 3, 4. So now it's time to run the merge step. And in the merge step, we want to give it the array, but we need to tell it where's the start and the end of the left half and the right half that we're trying to merge. Because we're going to try and merge this list, which is in sorted order, with this list that's in sorted order. So let's give it the array. Let's give it the starting index for the left-hand side, which is start. Let's give it the ending index for the left-hand side, which is mid. Then let's do the right-hand side. Start would be mid plus 1, and end would be end. Okay, so let's now create the actual merge method. And I'm going to name this start1 for the, or I guess I could name it start left, or let's call it left start. And let's call this one left end, and let's call this one right start, and let's call this one right end. So we've got a starting and an ending for the left half and the right half. Okay, so how are we going to do the merge? Let's create a temporary array. And even though it seems kind of wasteful to do, let's actually make the temporary array the exact same size as the original array, so that way, when we copy values over, we don't have to worry about changing the indices. We can just use the corresponding indexes. So what we want to do is left and right are both already sorted, but we need to combine them together. So we have to decide, we only have to look at the smallest number from the left and the smallest number from the right and decide which one of these is actually smaller and copy it over. And then whichever one is smaller, after we've copied it over, now we'll increment a pointer so that now we're looking at the next one. Just to keep all the things separate in our own minds, I'm going to call this L for left, and I'm going to call this R for right. And this is going to represent the current left and the current index for the smallest value from the left and the right. So we'll compare the left value to the right value. Left value is smaller, so we'll copy it here inside the temporary array, and then we'll increment the left value, so now it's looking at the next one over. And then it seems like we'll need to have a value here, which I'll call next lock, which is going to point at the next unassigned location for our temporary array. And so now I'm comparing left and right. This time right is smaller, so I'll copy the value at right into the index next lock. I increment next lock. I increment right because I've already copied that one. So now I compare again the value at left and the value at right. Right is smaller, so we assign it. Increment, increment. Compare the two. Right is smaller, we assign it. Increment, increment. Okay, so now we've assigned all the values in the right-hand part of the array that we sorted. So our index here has gone off the edge. So now we would want to stop the process of comparing the left and right lists. But there's still numbers left to assign. So after we're done comparing the smallest from the left and the smallest from the right over and over again, we still have to check if there are any unassigned values to copy over, and then just copy the rest of them over. So let's pretend we've done that, 5 and 9. Then the last step is we've got our merged list. This is our sorted list, but this is the temporary array. We've got to copy all these values back into the original array in the same locations that they used to be at. So we'll start looping here at start, and we'll loop from start all the way to the end, copying from temporary back to the original. So that's the merge step. Here was the slide where we talked about this. Here I'm using start 1, end 1 for the start and end of the left half, and start 2 and end 2 for the start and end of the right half. I'm creating the temporary storage array, and we're going to do this in a more efficient way in a minute. Current left and current right are like my L and R from what I just showed you. And so inside this while loop, this if-else statement is comparing the smallest value from the left to the smallest value on the right, and it's going to assign whichever one is actually smaller into the temp array, and then increment the pointer for either the left or the right. So inside this while loop, it only makes sense to keep going as long as there's still unassigned numbers from the left half and the right half. So we want to keep looping as long as the current left hasn't exceeded the end of the left list. As long as it's still less than or equal to the ending value, the ending index in the left list, we keep going. And as long as the right value that we're looking at is smaller than or equal to the ending index for the right list. So in other words, as long as we're still inside both lists, it makes sense to compare values and assign. And then the thing that we're missing here is we've got to increment next location, which is the index that we're going to copy into in the temporary array. As soon as one of the values on the left or the right exceeds the list, as soon as we've assigned all the values from one of the two lists, now we're done with the while loop because it doesn't make sense anymore to do the if-else statement. But there's still the possibility that there might be unassigned numbers. So we have to check to see if there's still things left to assign from the left, and if so, we loop to assign them. Same thing, if there's still numbers to assign on the right, we'll loop through and assign the rest of them. And then at the very, very end, copy all the values back from temp to array. So let's implement it. Okay, so I said the first thing we were going to do is create a temporary storage array, which is going to be the same size as the original array. Okay, very wasteful. We'll make it less wasteful in a minute. I'm going to make a current left, which is going to initialize to left start. And I'm going to make a current right, which is going to initialize to right start. And I'm going to make a next free, which is like, I think I called it next lock, which is going to initialize to left start because we're using corresponding indexes inside the temp array. So, anyway, so let's do that. Okay, so in the while loop, as long as current left is less than or equal to left end, and as long as current right is less than or equal to right end, so as long as we're still inside both lists, let's get the left value, which is going to be array current left, and let's get the right value, which is going to be array current right. And now let's compare them. So if left value is smaller than right value, then we'll assign it into the temporary array at next location. So that's going to be the left value because it was smaller. And then we want to increment next location no matter what, so let's move that outside the if-else. So otherwise, it must be that the right value is smaller than or equal to, so we'll assign it. And then no matter what we do, we want to increment next lock. Oh, I forgot to increment the left pointer and the right pointer here. So here, current left would need to increment. And then here, current right would need to increment. Okay. So that's going to assign the smallest value from the left or the right over and over and over again until eventually we've assigned all of the values from one of the two sides. So now we have to check to see if current left is still less than or equal to left end, then that means there's still numbers from the left list that we want to assign. So let's loop from, or let's not even do an if statement, let's do a while. So while this is still true, we're going to assign from the left. So we're going to take array current left, assign it to next lock, increment current left, increment next lock. And so we'll keep doing that until we're done with the left list. Let's do the same thing for the right list now. So while current right is less than right end, then we'll assign from current right, and we'll increment current right and next lock. So the reason I'm not using if statements here is because a while loop is like an if statement that happens to loop. So if it turns out that current left is already past left end, so we've already assigned all the elements from the left half, then this while loop will immediately evaluate to false for its continuation condition, and we'll just skip the loop. So it's sort of like an if statement. Okay, so then the very last thing we need to do is we need to loop starting from left start and going all the way, including right end. So the entire interval that we have merged together. And we're going to assign back to array from temp. So that copies all the values backwards. Okay, I believe that this should work. Let's try it. Oh yes. Let's convert our arrays to strings. Forgot about that. All right, let's try it again. Great, so this appears to have worked. And of course, this isn't, it doesn't mean there aren't still bugs there. I only tested it on one test case. But at least it seems to have sorted this test case. So let's make one more set of changes now. In your assignment, I mentioned several things to make it a little bit nicer and a little bit more efficient. So here, it's sort of a pain to force somebody running merge sort to have to say, let's start at the beginning and end at the end. What they really want to do is they really want to do something like this. They want to say, let's just merge sort my whole array and have this magically work. So let's make a convenience method for them. I'm going to overload the merge sort method so that it'll just take an array as input. So this, I'm not going to re-implement the same algorithm. That would be wasteful. Instead, I'm going to have this be sort of like a default behavior where if you just give them the whole array, then what we're going to do is we're going to run our real merge sort on that array starting at 0, ending at array.length -1. So this is like just a convenience method. So now they don't have to run this one. They can just pretend like they're running merge sort on the array. And then that method actually takes care of deciding where the beginning and the ending should be. So that's the first change. And that's pretty common. You've noticed that a lot of our recursive methods have parameters for the portion of the input that we're operating on. But you don't want to force somebody using your method to think about that. So instead, you create a method without those parameters, which is the one that you intend the users of your code actually to run. Okay, so then the second thing is, it's pretty wasteful here to keep creating this temporary array over and over and over again every single time we run merge. So instead, let's do this. Let's create this temporary array up here before we start running the merge sort at all. And then we'll pass the temporary array as a parameter. Or as an argument, I guess I should say, because now I'm only creating it once, and then it's always there available to be used. So we're not continually recreating it. So I need a new parameter here to hold the storage, which means that I've got to pass it here and here. And then let's also pass it into the merge step, which means here I've got to take an int array called temp. And so now it's all going to work in the same way, except I'm not creating the temporary array inside merge. So let's run it one more time, confirm that it's still doing the same thing. Yay, still doing the same thing. Okay, I hope that this was helpful. So in your work now, spend a little time trying to correct it, but then mainly what I want to see from you is whichever part of this was confusing for you. If it was these parameters, if it was what you do over here, if it was this part of the while loop, I want to hear about kind of what was your thinking before and what do you understand now. Thanks so much.